This is solving rational equations. This is Unit 4, Lesson 5. So we're going to talk about solving rational equations. Our objective is you're going to solve rational equations by creating equivalent expressions and set up rational equations to model and solve real-world mixture and rate problems. So imagine streaming a movie while someone else hogs Wi-Fi for gaming. I know you're all familiar with that. The total speed you both use decides if the movie buffers. Figuring out combined speeds is like solving rational equations with rates. When you learn this trick, you can predict who slows everyone down. So let's dive in. Rational equation is an equation containing one or more fractions whose numerator and denominators include a variable. Because the denominator can change value, we must consider values that make denominators zero. By rewriting each fraction with an equivalent expression, we can solve for variables while staying within allowed values. So keywords here are rational equations. Those are equations with variables inside a fraction. And those denominators is the bottom part of the fraction that shows how many equal parts we have. Let's use equivalent expressions to solve 1 divided by 2x minus 3 divided by 2x squared equals 1 over x. So we have an equation here. That means there's an equal sign in there that we are trying to solve for x here. The first thing we're always going to want to do is check for any undefined values. How you decide whether values cannot be replaced into your expressions is by setting the denominators equal to 0 to find those undefined values. You're not allowed to divide by 0 or it has an undefined answer. So we need to figure out what numbers would make our denominators 0. So setting each of the denominators, 2x equals 0, 2x squared equals 0, and x equal to 0, we would actually want to find which ones do not equal 0. So if we solve for x in each of these expressions, let's see here. If I divide by 2 on both sides, I get x equal to 0. Which I do not want, so I cannot have x equal to 0. If I replace 0, x with 0 in any of these denominators, that is going to make my fraction undefined. Okay, so we always want to make sure we solve for any of those undefined values. Step 2, next you're going to want to find the least common denominators. So you're going to multiply the terms on both sides of the equal sign by the least common multiple to get the least common denominator. So in this case, our least common denominator is 2x squared. So I would need to simplify, I would need to multiply the terms to make all of the denominators the same. So my first term, 1 over 2x, if I want to turn the denominator into 2x squared, I would just need to multiply that by x. Since I did it to the bottom, I also have to do it to the top. So I would actually be multiplying it in the form of 1 with x over x. The second term is already has the denominator of negative 2x squared, so I do not have to multiply that one. My last term is on the other side of the equal sign, 1 divided by x. If I want to turn that into 2x squared, I would need to multiply it by 2x over 2x. So once I do all of the multiplication, I have a new equation, x divided by 2x squared minus 3 divided by 2x squared equals 2x divided by 2x squared. Now I can combine like terms in the numerator, and I can drop the denominators. This is the denominator, I don't know why that's got that in it, since they are equal. So all of the numerator now would just be x minus 3, and that would be set equal to 2x. I can drop my numerators to give me this simple equation here, x minus 3 equals 2x. Solve and check for extraneous solutions is your final step. Use algebra to isolate the variable. Substitute the solution into the equation for the variable to check for extraneous. Extraneous means it may have given us an answer, but if I plug it back in, does it give me a 0? And which in turn I cannot have a 0. So x minus 3 equals 2x. I'm going to subtract x to move it to the other side with the other variable. And that's going to leave me with x equals negative 3. I'm going to take the negative 3 and substitute it back into my original equation here, my original equation. Anywhere there's an x, I'm going to put negative 3 in, and I'm going to solve it till I get the same on both sides. Negative 6 over 18 equals negative 6 over 18. That is the same, so that is checked, and it is a viable solution, not extraneous. So let's see if we can practice that a little bit now that you've seen this example. Answer both questions and show your answer and thinking on your paper. Take yourself a break here and pause it and spend 2 minutes seeing if you can apply what we just learned to these two equations. All right, so on number 1, it looks like both of the equations on the right have the same denominator. The one that doesn't is the one on the left. So does that mean I can just add here? No, I have to make one have the same denominator. So I'm going to multiply 1 by 6m minus 5 over 6m minus 5. And that's just going to give me 6m minus 5 over 6m minus 5. Now they all have the same denominator. So I can drop the denominator and just keep the numerators and have a new equation there to solve. I'm going to combine my like terms. 8 minus 3 is where my 5 is coming from here. I'm going to subtract m from both sides to give me, I'm going to come over here, 5m minus 5 equals 5. Then I'm going to add 5 to both sides to give me 5m equals 10, and divide by 5 to give me m equals 2. Now, what did I forget to do? At the very beginning, I should have set the denominator equal to 0 to find my undefined terms. So let's go ahead and go back to do that. 6 minus m equals 5 is my denominator. I'm going to set that equal to 0 and solve. 6m equals positive 5 and m equals 5 over 6. Okay, so my m cannot equal 5 over 6. So I got m equals 2. Now I'm going to check it to make sure that it is not extraneous. So anywhere in my original problem where I have an m, I'm going to replace that with 2. 1 minus 8, 1 equals 8 over 6 times 2 minus 5 plus 2 minus 3 over 6 times 2 minus 5. That's going to give me 1 equals 8 divided by 12 minus 5, which is 7, plus 2 minus 3 is negative 1, over 7. So 8 plus negative 1 is going to equal 7 over 7. And that is the same as 1 equals 1. So 2 is definitely going to be my solution. How'd you do on that one? Let's solve for the second one here. I'm going to rewrite this second one as a fraction that looks appropriate. I'm going to write 2 over y minus 1 equals 3 over 4. It's hard to see when those slants in there. So now that I've written it that way, what am I going to use as my common denominator? We're going to use 4 times y minus 1. So I want both of my denominators to be 4 times y minus 1. That's your least common denominator. So what did I have to multiply the left side by to get 4 times y minus 1? I had to multiply it by 4. So I have to do that to the numerator. That's going to give me 8. On the right side, I had to multiply it by y minus 1. So that's going to give me 3y minus 3. Now I can drop the denominator. Just leave me with the numerators to solve for y. Again, what did I forget to do first? What did I forget to do first? I didn't set the denominator equal to 0 to find out what y cannot equal. So y cannot equal positive 1. All right, so let's go back to continue here. Adding 3 to both sides gives me 11. Dividing by 3 gives me 11 divided by 3. So y is 11 divided by 3. I'm not going to go ahead and check that one for lack of time, but it did not equal 1, so it would be a solution. And if I did plug it back in, I would find that it also works out to be equal on both sides. So y equals 11 over 3 is my answer. You can check it if you like and see that it does work out. Okay. How are you doing so far? Are you catching on to what we are trying to work on here? All right. There we go. Those are answers. And let's talk about when we have to factor in order to simplify. So now we have a problem, k squared minus 4 over k squared plus 4k equals 1 over k plus 1. We want to begin the problem by factoring any expressions in the denominator that can be factored. In this case, we can factor out a k out of the k squared plus 4k. That leaves us with k times k plus 4. Now we can see we have several denominators here that we need to set equal to 0 to find those undefined terms. We have k and k times k plus 4. So we're going to set k equal to 0, k equal to 0, and k plus 4 equal to 0. So k is going to equal negative 4. So we know k cannot equal negative 4 and k cannot equal 0 when we find our solution. Then we're going to multiply the terms on both sides by the least common multiple to get the least common denominator. Our least common denominator here is going to be k times k plus 4. So we need to multiply all the parts by what turns it into the denominator. So if I have the first term here already has k and k plus 4, we already have that in the first term. I don't have to do anything to the numerator. The next term, k, is missing the k plus 4, so I have to multiply it by k plus 4 here. And then the 1 is missing both the k and the k plus 4, so I have to multiply it by both. That's going to leave me now with k squared minus 4 equals k plus 4 plus k times k plus 4. And then when I combine those the like terms, it's going to leave me with a trinomial k squared plus 5k plus 4. Now I have to drop the denominator, and I have this equation left to solve using algebra to isolate those variables. We're going to use substitute that solution into the equation for the variable to check its solution. When I solve it, I get k equals to negative 8 over 5. If I plug in that negative 8 over 5, I do find that it is a solution. We're going to continue practicing that, plugging it in. So I'm not going to do it right here, since just to save time, we're going to do it on some problems in just a second. Okay. So let's practice. Work it out. Subtraction requires caution here. All right, so pause the video and see if you can find the least common denominator. Don't forget that you need to factor to make sure you have simplified the denominators first. All right, first thing we're going to do is factor the denominator here, x squared minus 9x plus 20, into its linear form. And that's going to give me, what are the factors of 20 that add up to negative 9? That would be x minus 4 and x minus 5. All right, so now you see some similarities there, right? So our least common denominator is going to be x minus 4 times x minus 5. So the first one here has x minus 4 in it, so I just need to multiply it by x minus 5. The second one has x minus 5, so I need to multiply it by x minus 4. What I have now is 2 times x minus 5 is equal to x minus 4 minus 2x, and I'm going to do this whole thing here because I'm subtracting all of it, 2x squared minus 6x minus 36. All of it. Let's do our distribution here. 2x minus 10 equals x minus 4 minus 2x squared plus 6x plus 36. So I distributed this negative sign right here. That's to go to each one of those terms. Let's continue by combining those like terms. I have negative 2x squared plus 7x plus 32. Let's set everything equal to 0. So I'm going to subtract 2x and add 10 to both sides to give me 0 equals negative 2x squared plus 5x plus 42. Now I like my 0 on the other side. You can continue to solve it this way, but I think I'm going to just move my 0 to the other side here. So I'm going to change my signs to x squared minus 5x minus 42 equals 0. And now I can factor by either grouping the quadratic formula, however you find it's easier to do this factoring, we're going to do it. And I'm going to go ahead and give me some more writing room here. So I have I had 2x squared plus, nope, minus 2x squared minus 5x minus 42 equal to 0. I'm going to break up the middle, 2x squared plus 12x minus 7x minus, minus 12x plus 7x minus 42 equals 0. So I broke up the 5x into negative 12x plus 7x. And now I'm going to use my grouping method. Okay. Factoring out a 2x here leaves me with x minus 6. Factoring out a 7 leaves me with x minus 6 equals 0. 7 equals 0, and x minus 6 equals 0. So what is 2x minus plus 7 equal to 0? How do I solve that? Well, I'm going to subtract 7 to both sides. That's going to give me negative 7. And then I'm going to divide by 2, and that's going to give me negative 7 over 2. This one's going to give me x equals 6. Okay. So I have two expressions there. What did I not do again? I should have done. I have to get in the habit of that. I've always done it last, but this wants you to do it at the beginning. We were supposed to set all of those denominators equal to 0 to find x cannot equal 4, x cannot equal 5 on both of those. So x cannot equal 4 and x cannot equal 5. So I did not find either one of those as my answers. So let's check for extraneous solutions, okay? So I'm going to substitute my answer, which I found x to be, remember, negative 7 over 2, and I also found x to equal 6. So I need to do two checks here. If x is equal to negative 7, I'm going to substitute that in. Negative 7 over 2 minus 4 equals 1 over negative 7 over 2 minus 5 minus 2 times negative 7 over 2 squared minus 6 times negative 7 over 2 minus 36. And that's all over negative 7 over 2 squared minus 9 times negative 7 over 2 plus 20. Now, you all can bring in Desmos and to do this work for you, your calculator work. I would highly suggest that you do that. Absolutely. What you're going to get here is 1 equals 1. So that is going to be true. Okay, when you substitute in for 6, you're going to get 1 equals to 1. When you substitute in 7/2, you're going to get 0.26 equals 0.26. So those are going to both be solutions. So I'm good to keep both of those. I do not need to reject either one of them because they do not make an undefined term when plugged back in. They don't come up with x equals 0. If they came up with x equals 0, then I would reject the solution. All right, remember, do that all on the calculator in Desmos, however you like, but make sure you're checking for those extraneous solutions. Okay? All right, now let's work this one out Hint, hint. It says don't extrain yourself. Don't extrain yourself. All right, I'm going to remember this time to do the denominators. X plus 6 equals 0 and x minus 6 equals 0. So x cannot equal negative 6 and x cannot equal positive 6, okay? Those would make them undefined. My least common denominator is going to be x plus 6 and x minus 6. So I need to multiply the first one by x minus 6. That's going to be equal to 72. I need to multiply the 4 by x plus 6 and x minus 6. Don't forget that 4 out there. Now I've dropped the denominator already. Let's go ahead and do our distribution. So I have x squared minus 6x equals 72 plus 4 times x squared minus 36. Keep going. X squared minus 6x equals 72 plus 4x squared minus 144. Let's combine like terms before we start moving anything. Now let's get everything to one side and set it equal to 0. All right. Now we have it all equal to 0. We want to factor it. And I think I'm going to take out a GCF of 3 here. Yes, that works. It's still equal to 0. So let's come over and try to factor down that x squared. So that's going to leave me with 3 times x plus 6 and x minus 4. That's still equal to 0. Now, if you are still struggling with your factoring, remember we've done a lot of practice on factoring, so you need to know how to do this factoring. Now that we have all of that, we're going to set the x plus 6 equal to 0 and the x minus 4 equal to 0. What am I going to do with the 3? The 3 definitely does not equal 0, so it is not a solution. I get x is equal to negative 6 and x is equal to positive 4. Well, looking at that, we know that x is not able to be equal to negative 6. So I only have one solution here, and that's going to be x equals 4. Now feel free to substitute that in. If x equals 4, I'm going to plug that in wherever there is an x. Just need 4 over 10 over here, and 72 over 10 times negative 2 plus 4, 72 over negative 20. 4 is 80 over 20. Okay. So this negative is going to come out here. And so 80 minus 72 is going to be 8 over 20. And 4 over 10 does equal 8 over 20 when we simplify that down by dividing it by 2. So that does work. Absolutely does work. Make sure you are checking for those extraneous, and we did a good job by doing that first on this one. Past it? Nope, I want this one. Okay. Now let's get to a little bit different of a problem here. It doesn't look as complicated. we have 2x and 24 in the denominator. So my least common denominator is going to be 24x. 24x is my least common denominator. Let's check though for those, set them both equal to 0, so x cannot equal 0 here. Okay, x cannot equal 0. So if I'm going to turn the first one into 24x, that means I need to multiply that by 12. So 72 over 24x equals, the next one I just need to multiply that one by x over x equals 5x squared over 24x. So I can just take the numerators now, set them equal to each other. I would solve for x first by dividing by 5. 72 divided by 5 equals x squared. Well, now I have to take the square root of both sides, and know when you take the square root of both sides, you're going to get a positive and a negative. 72 over 5 to equal your x. And that does not equal 0, so we are okay. That is going to be a solution. Know that when you have a square term, there's going to be two answers. Okay, two answers, which is where the positive and the negative comes in. This is actually x equals positive square root of 72 over 5 and the negative square root of 72 over 5. Because you remember that negative 2 squared and 2 squared are the same 4. Okay? Negative times a negative is a positive, and a positive times a positive is a positive. All right. How'd you do on that problem? Let's work this out. Don't hate a reject. Don't hate it. Don't hate the rejects, okay? Let's just work it out. Let's set the denominator equal to 0. X minus 5 equals 0, so x cannot equal positive 5. So according to my title there, I bet I'm going to have a solution of 5. They all have the same denominator, so I don't have to do any multiplication here. I can simply set the numerators to each other and do my like terms. Add 30 to both sides. Divide by 10. Guess what? I get x equals a 5. So I know that it cannot be equal to 5, so this is going to have no solution. This is going to be rejected. Rejected, rejected, rejected. It's pretty easy when you don't have to do anything to the denominator there, right? Keep trying some more. All right.